SSD or solid-state drive is a type of semiconductor memory that's also called flash memory and has features such as high speed, power saving, small size and lightweight, and impact resistance. In addition, it'll be widely used as dedicated storage that requires extremely high-speed processing such as databases and large-scale arithmetic systems specializing in quick reading and writing of data. On the other hand, compared to HDD or hard disk drive, the unit price per capacity is high at the moment, so the range of use is limited. Hey guys, welcome to another very exciting video from our channel, How's It Made? Before jumping into the video, if you're new here, please consider subscribing to our channel. Also, hit the bell icon to get notification whenever we upload a new video. With that said, let's begin. Overview of SSD. Due to their characteristics, SSDs are widely used in small digital devices such as digital cameras and portable music players. Below, let's compare the features with HDD. Merit of SSD. Since there's no physical head movement like HDD, data reading and writing is fast, and it's especially excellent for random access. Another major feature is that there's no drive part. It's hard to break down, eliminates the anxiety of breakdowns around the HDD, which is the most common in personal computers and is also effective in terms of energy-saving effect because it doesn't require a lot of power. When SSD-equipped storage is used in a data center, the features of small semiconductors can be utilized to save space and costs. It's attracting attention as one of the green ICT. Demerit of SSD. At present, the production volume is still smaller than that of HDDs, and the unit price per capacity is relatively high. Also, compared to HDDs, which have products of tens to hundreds of TB, SSDs are still mainstream from hundreds of gigabyte to tens of terabyte. HDD has superior in capacity. Outlook of SSD. Due to the above merits of power saving, small size and lightweight, and impact resistance, it'll be used in notebook computers. If it saves power, the battery will last longer, and it's small and light. It's useful on mobile, including impact resistance. In addition, it'll be widely used as dedicated storage that requires extremely high-speed processing such as databases and large-scale arithmetic systems specializing in quick reading and writing of data. On the other hand, regarding the price that's mentioned as a disadvantage, it can be expected that the unit price will decrease if it's mass-produced. In the future, as SSDs become cheaper, they'll be used in a wider range of fields from the current limited applications. For example, HDDs are used for backup destinations or places where there are a few opportunities to use, and SSDs are used for places that are frequently accessed. SSDs use flash memory chips to store information, and one SSD has multiple memory chips installed on a circuit board. At Micron, similar to how to make computer memory, we manufacture flash memory chips from silicon wafers at our own factory. Silicon wafers are easily contaminated, so robots move the wafers to perform more than 800 processes. This process will take over a month to complete. As the wafer goes through the process, many layers of material are layered on top of the wafer. This layer has some conductors like copper and some non-conductors like silicon dioxide. After applying layers of each material, the wafer is coated with a photosensitive liquid and exposed to UV light through a glass stencil with an electric circuit pattern. When ultraviolet rays hit this material, the material undergoes a chemical change and melts. The material in the stencil-protected area remains intact and the circuit pattern is printed on the wafer. Rinse off excess material in a chemical bath. After printing, a 30-centimeter wafer produces hundreds of chips, which are sliced and carved. After the tip is cut and separated, it's placed in a protective plastic housing. Large circuit boards are covered with tin alloy solder paste where memory chips and other components are attached. The robot attaches the parts to the base, and then the assembled base is placed in an oven to melt the parts into the base. Silicon wafer graded quality management. The board is first checked by optical scanning to see if the components on the board are in the correct position, and then use the following X-ray machine to check that the board is soldered in the correct position. This large circuit board is then cut and then inserted into the plastic housing for a 2.5-inch drive. Each drive is then labeled with the model number, serial number, technical specifications, and other information. This includes the barcode for product tracking as one of the drive information. This drive is connected to a tester to perform functional verification and install the firmware that runs the drive. After that, we perform performance verification for up to 60 hours to see if the drive can store data correctly and can read and write at the target speed. Micron SSDs are also tested on various motherboards to ensure wide compatibility. The drive is then packed in an anti-static foil bag and placed in a carton. Micron SSDs are finally shipped worldwide from here. Applying solder paste by the robot. Micron is one of the few manufacturers that manufacture SSDs from silicon. The drive is guaranteed with consistent quality control throughout the process. With tools like Crucial Advisor or System Scanner, it's right for your storage needs, form factor, interface, and size can be found. That's it, guys. Let us know if you found this video informative in the comment section below. Also, if you like this video, give it a thumbs up and share it with your friends. And don't forget to subscribe to our channel for more informative videos. See you in the next video.